When modifying parking lot lighting that is fed through buried conduit and splicing becomes necessary due to relocating some lights, several methods are available. Each has its own advantages and disadvantages. The method involves a vault splice. This involves installing a precast concrete or plastic vault at a convenient location. The advantages are it provides a protected enclosure for splices, offers easy access for future maintenance, and minimizes the need for digging up paved areas. However, it requires vault installation, which can be costly, and there is limited space for multiple splices. A procedure involves firstly, installing a precast concrete or plastic vault at a convenient location, secondly, pulling the conduit into the vault and cutting it to length, thirdly, making splices inside the vault using waterproof connectors or heat shrink tubing, and fourthly, backfilling the vault with sand or gravel. Another method involves a pull box splice. The advantages are it is less expensive than a vault splice, smaller and more compact, and can be used in tight spaces. The disadvantages are it offers less protection for splices and requires digging up paved areas for access. The procedure involves firstly, installing a pull box at a convenient location, secondly, pulling the conduit into the pull box and cutting it to length, thirdly, making splices inside the pull box using waterproof connectors or heat shrink tubing, and fourthly, sealing the pull box lid with silicone caulk. A third method involves a direct burial splice. The advantages are no additional equipment or materials are required and it's simple and cost-effective. The disadvantages of splices are exposed to moisture and dirt and it's more difficult to access for future maintenance. The procedure involves firstly, digging a trench at the splice location, secondly, cutting the conduit and making splices using waterproof connectors or heat shrink tubing, and thirdly, burying the splice in the trench and backfilling with compacted soil. For long conduit runs with multiple lights, vault splices are generally preferred due to their superior protection and ease of maintenance. For shorter runs with only a few lights, pull box splices may be a more suitable and cost-effective option. For small splices in tight spaces, direct burial splices can be considered, but it is crucial to take proper waterproofing measures to ensure the longevity and reliability of the splice. Always use waterproof connectors or heat shrink tubing rated for direct burial applications to prevent moisture from compromising the electrical connections. Protect splices from mechanical damage by carefully backfilling the area with compacted soil and avoiding any sharp objects that could potentially harm the splice. It is important to document the locations of all splices for future reference. This will help in locating and accessing the splices if any maintenance or repairs are required down the line. This documentation could include detailed diagrams, photographs, or GPS coordinates to ensure accurate identification of splice locations. When selecting a method, consider factors such as the number of lights, the length of the conduit runs, the available space, and the budget. Vault splices provide the best protection and accessibility but are the most expensive. Pull box splices offer a good balance between cost and protection. Direct burial splices are the least expensive but offer the least protection and accessibility. Regardless of the method chosen, always follow all applicable electrical codes and safety regulations to ensure a safe and reliable installation. It is crucial to use proper personal protective equipment such as gloves and eye protection when working with electrical wiring. Always disconnect the power supply before making any splices or connections. Verify that the power is off using a reliable testing device. Use only approved materials and equipment that are suitable for the intended application. Ensure that all connections are tight and secure to prevent loose connections, which can cause overheating and electrical hazards. Consider the environmental conditions in the area when selecting splicing materials and methods. In areas with high moisture levels or corrosive soils, it is especially important to use waterproof connectors and materials that are resistant to corrosion. Properly seal all splices and connections to prevent moisture from entering and causing damage. Use silicone caulk or other suitable sealant to seal any openings or gaps in the splice enclosure. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the splicing work. An experienced electrician will have the knowledge and skills to ensure that the job is done safely and correctly. Regular inspections of the splices and conduit system are recommended to identify any potential problems early on. Look for signs of damage, such as cracks, corrosion, or water intrusion. Address any issues promptly to prevent further damage and ensure the continued safe and reliable operation of the parking lot lighting system. Consider using a ground fault circuit interrupter, or GFCI, to protect the lighting circuit. A GFCI will detect any ground faults and immediately shut off the power, preventing electrical shock. For direct burial splices, use a high-quality direct burial splice kit that is specifically designed for underground applications. These kits typically include waterproof connectors, heat-shrink tubing, and sealant to provide a reliable and long-lasting splice. When backfilling the trench after making a direct burial splice, be sure to compact the soil properly to prevent settling. Settling can cause the splice to become exposed or damaged. If the conduit is damaged or corroded, it is best to replace it entirely rather than attempting to splice it. Damaged conduit can compromise the safety and reliability of the electrical system. When working with underground conduit, be aware of the potential for underground utilities. Before digging, contact your local utility companies to locate any underground lines. This will help prevent accidental damage to underground utilities, which can be dangerous and costly. Document the type of connectors and materials used for each splice. This information can be helpful for future maintenance and repairs. It is also a good idea to take photographs of the splices before backfilling the trench. These photographs can serve as a visual record of the splice location and the type of connections used. Consider using a cable locator to help locate the buried conduit. A cable locator can detect the presence of underground cables and pipes, making it easier to find the conduit without having to dig up large areas. When selecting a pull box, choose a size that is large enough to accommodate the splices and the conduit. The pull box should also be weatherproof and corrosion resistant. When installing a vault, be sure to follow the manufacturer's instructions carefully. The vault should be installed on a level surface and backfilled properly to prevent it from shifting or settling. If the parking lot is subject to heavy traffic, consider using a reinforced vault or pull box to protect the splices from damage. Consider using a surge protector to protect the lighting system from power surges. Power surges can damage the lighting fixtures and the splices. If the parking lot is located in an area with frequent lightning strikes, consider using a lightning arrestor to protect the lighting system from lightning damage. Remember to consult with a qualified electrical engineer or contractor to determine the best splicing method for your specific application. They can assess the site conditions, electrical load, and other factors to ensure that the splices are done safely and in accordance with all applicable codes and regulations. By following these guidelines, one can ensure that the buried conduit splices for parking lot lighting are done properly and will provide a safe and reliable electrical system for years to come. Remember, safety is paramount when working with electricity. Always take the necessary precautions to protect oneself and others from electrical hazards. If there is any doubt, consult with a qualified electrician.